Hello everyone, I am Dr. Neema and this is my introductory lecture on the atomic structure. Here, we'll take a look at the scientists, their experiments, and the theories that helped in establishing the concept of an atom. So where did it all begin? The concept of atom was first introduced around 400 BC by a Greek philosopher named Democritus. Democritus suggested that all matters are made up of tiny particles that he termed as atoms. Now, atom is derived from a Greek word atomos that means indivisible or uncut. So, according to Democritus, atoms were indestructible, unchangeable, and also homogeneous. By homogeneous, he meant that they do not have any internal structure. So the first atomic model was presented by Democritus and it was a solid. Now this theory, even though right, was rejected for almost 2000 years by scientists and philosophers because at that time they thought that matter is in fact made up of the four elements, that is earth, fire, water and air. So once again, the idea of atom was introduced by an English scientist named John Dalton in around 1808. Now, John Dalton stated that atom is the smallest unit of matter that takes part in a chemical reaction. Now, even though Dalton's atomic theory has been modified over the years in order to include the new discoveries, still it was so insightful that even today it remains essentially intact. The important points of Dalton's atomic theory were: all matter is composed of atom. Now this is the same idea that Democritus had already suggested in around 400 BC. The second part of Dalton's atomic theory stated that atoms of same element are same, but atoms of different elements are different. By this he meant that atoms belonging to one particular element are same in all respect, but they are different than atoms belonging to a different element. The third part of Dalton's atomic theory stated that compounds are a combination of two or more different types of atoms. If we take table salt for example, we see that it is made up of atoms of sodium and atoms of chloride. So according to this postulate, compounds are actually formed when atoms of two different elements or more come together. Now the fourth part of Dalton's atomic theory suggested that chemical reactions do not destroy nor create atoms. According to Dalton, the chemical reactions are merely formed by the rearrangement of atoms, and in the process, they do not get destroyed nor new atoms get created. Now, if we see all these postulates and theories, they form the basis of chemistry even today. Along with Dalton's atomic theory, in the late 18th century and the early 20th century, a lot of other renowned scientists like Thomson, Rutherford, Bohr, Goldstein, etc., they were also conducting their own experiments to find out more about this atom. And the conclusion of their experiments proved that atom is not the smallest unit of matter. It is in fact divided into subatomic particles. Now the first subatomic particle to be discovered was electron. Electron carries a negative charge. An electron was first discovered by J.J. Thomson while he was studying the properties of cathode rays. In his experiment, Thomson prepared a discharge tube that was partially evacuated. That means a condition of vacuum was created inside the tube. Then he placed two oppositely charged electric plates on either side of the discharge tube, as you can see in the figure, and he used perforated cathode. He named the end that was positive as anode and the electric plate that was negatively charged as cathode. When he applied a high voltage of around 1000 volts, Thomson observed that a beam of ray was passing from the cathode and moving towards the anode. He called these rays as cathode rays, and Thomson started studying the properties of these rays by deflecting the electric and magnetic fields. The properties that he then enlisted were that cathode rays travel in straight line, cathode rays can cause fluorescence, these rays get deflected in both electric as well as magnetic fields, they produce heat and X-rays, and lastly, cathode rays can affect photographic plates. It was these cathode rays that were later given a more familiar name, that is electron, and for the same, Thomson won the Nobel Prize in 1906. Thomson also observed that cathode rays were not characteristic of the gas filled in the discharge tube, and therefore he concluded that cathode rays, that is electrons, are fundamental particles present in all elements. Now, some of the other properties of electrons that were later studied by other scientists along with J.J. Thomson was: first, J.J. Thomson only measured the charge by mass ratio of cathode rays, and that came to around 1.75 into 10 to the power 11 coulomb per kilogram. But the exact charge of an electron was only measured by Robert Millikan when he performed his oil drop experiment. In his experiment, Robert Millikan measured the charge of an electron against the negatively charged oil particles, and it came to around 1.602 into 10 to the power minus 19 coulomb. Along with that, he used these values to also calculate the mass of the electron, which came to around 9.10 into 10 to the power minus 28 grams. Now, it was a known fact that atom is a neutral species. So after the discovery of electron, scientists started working towards finding its positive counterpart. In that regard, Goldstein struck gold while he was performing his experiment on the discharge tube in 1886. In his experiment, he changed the experimental conditions a bit, that he used perforated anode instead of perforated cathode, and he even lowered the pressure inside the discharge tube. On the application of voltage, Goldstein observed that along with cathode rays, there were also a beam of ray that was originating from the anode and moving towards the cathode. He called these rays as anode rays or canal rays and started studying their properties. He managed to measure the charge upon mass ratio, and he found out that it was maximum when he was using hydrogen as the gas in the discharge tube. So Goldstein suggested that these anode rays actually consist of hydrogen nucleus, and they are characteristic of the gas in the tube. Now, several years later, in 1917, Rutherford actually discovered that hydrogen nucleus is present in all elements. So he stated that all elements contain hydrogen nucleus, and he named this hydrogen nucleus as proton. Proton is also derived from a Greek word that means first. So since it was Rutherford who actually verified Goldstein's discovery, and he actually named proton, the majority of the credit for the discovery of proton actually goes to Rutherford instead of Goldstein. Now next comes the discovery of nucleus. Nucleus was discovered in a gold foil experiment around 1909 that was conducted by Hans Geiger and Ernest Marson under the supervision of Rutherford. In their experiment, Rutherford bombarded a beam of alpha particles onto an ultra-thin gold foil and studied the scattering pattern. He observed that most of the alpha particles could easily pass through the gold foil and they hit a screen of zinc sulfide that was placed beyond it. Also, a few of alpha particles were seen to be deflected by small angles, and even lesser portion of alpha particles was deflected by 180 degrees. According to all these observations, Rutherford concluded that most of atom's mass and its entire positive mass is actually confined in a small core called nucleus, which is present at the center of the atom, and it is this core that is deflecting the alpha particles with 180 degree. Secondly, he suggested that positively charged particles, that is protons, are present in the nucleus. In the third part, he suggested that most of the volume of atom is empty since most of alpha particles could easily pass through the gold foil. And lastly, his theory was that the number of negatively charged electrons are dispersed around the nucleus that are causing the deflection of alpha particles by some angles. So on the basis of all these observations and conclusions, Rutherford postulated the first atomic model called as Rutherford's atomic model. In his model, Rutherford envisioned an atom to be a miniature solar system with electrons revolving or orbiting around the nucleus. Since at that time only two elementary particles, that is electrons and protons, were discovered, Rutherford concluded that protons are present inside the nucleus at the center of the atom, while electrons are found outside it, as you can see in the figure. Now, even though Ruther's atomic model was quite correct and it could explain certain facts, still it failed to verify some of the other theories that were being put forward by other scientists. For example, Maxwell at that time suggested that any charged particle, when accelerated, tends to radiate energy. When this theory is applied on Rutherford's model of an atom, then an electron, being a negatively charged particle, when orbiting around a nucleus, should emit radiation, should lose energy, and should eventually collapse into the nucleus. But that was not so. In fact, atom was very much stable. The second drawback of Rutherford's model was that it failed to explain the line spectrum that was observed when atom was experimented upon. So it is these two drawbacks or the limitations that made other scientists reserve their comment on accepting the Rutherford's model of atom completely. So now till 19th-20th century, scientists believe that only two elementary particles, the electrons and the protons, make up an atom. However, this atomic model posed a lot of scientific and theoretical contradictions. For example, scientists observed that the entire mass of an element could not be accounted for just on the basis of electrons and protons. And it was this confusion that led to the discovery of neutron. How neutron got discovered, I would like to share a video with you all that will clear the concept nicely.
Scientists observed that all mass of an atom cannot be accounted on the basis of just electrons and protons when James Chadwick used scattering data to calculate the mass of this neutral particle. For example, the atomic number of helium is 2 and the atomic number of hydrogen is 1. So, the atomic mass of helium should be double of the hydrogen atom. However, on calculation, the mass of helium atom was found to be 4 times more than that of hydrogen. It was the big reason for the discovery of the neutron. In 1930, Bothe and Becker bombarded a piece of beryllium with alpha particles from a radioactive source, produced neutral radiation which was penetrating, but non-ionizing. They observed a penetrating radiation emerging from the beryllium that they thought to be gamma rays. When a piece of paraffin wax was placed in the path of the beam, however, the reading on the detector actually increased. It was realized that the increase in reading was due to the emission of protons from the wax, and they tried to work out how this could be happening. If the proton emission had been due to bombardment of the wax by gamma radiation, the gamma rays would have to energy of around 16 MeV, very large for such a reaction. In the year 1932, James Chadwick conducted the same experiment, but he used different bombardment targets other than paraffin. After research and analysis of the various targets, he discovered the presence of a new particle. This new particle has a mass similar to that of the proton, but no charge. He named these particles neutrons. Furthermore, he derived the nearly accurate mass of this new particle by applying the conservation of energy and momentum. He measured the mass of a neutron to be nearly the same as that of a proton. Mn equals 1.00866 U equals 1.6749 by 10 to 27.
So the search was over. The third elementary particle of an atom, that is neutron, was discovered. Neutron didn't add any extra charge to atom, but doubled the atomic mass of the element. Now the three subatomic particles, the electrons, protons, and neutrons, not that they were discovered, scientists also successfully measured the properties of all these particles. The proton being positively charged, neutron being neutral, and electron being negatively charged. The properties I have enlisted in this table for you all to note down. Now, how are these particles actually arranged in an atom? Well, they are not placed randomly. In fact, it is quite in accordance to what Rutherford had already proposed, that protons are present inside the nucleus with electrons circulating around it. The only difference here is that nucleus contains proton as well as neutron and is present at the core of the atom. Electrons are present outside this nucleus and they orbit around it. So this is the structure what I have shown in the slide of the ultimate atom that was successfully accepted by all scientists. Thank you. So that will be all for now. Hope you found the lecture informative.